In this problem, we are given a fairly complex circuit diagram. We are asked to find the equivalent resistance seen by the source and the power absorbed by the 5 ohm resistor. First, we're going to look at the equivalent resistance. We can see that this 2 ohm resistor, this 8 ohm resistor, and this 5 ohm resistor are all in series. That means this is going to be 15 ohms. Now we can see that our 6 ohm resistor, our 10 ohm resistor, and the combined 15 ohm resistor are all in parallel, so we're going to use the parallel formula for resistors. We're going to have a 1 divided by our 6 plus a 1 divided by our 10 plus a 1 divided by our 15. This is all then going to be raised to the negative first power, and if we set this equal, we're going to get 3. These are all of our resistors in our circuit, so we're just going to have 3 ohms for our R equivalent. Now we're asked to find the power absorbed by our 5 ohm resistor. For this specific example, we are going to use the power is equal to our current squared times resistance. There's 3 different formulas we can use, linked below in the notes, somewhere in chapter 2, I think. The reason why we're going to be using this one specifically is because we are given resistance, so that's an automatic plus, an indication of what we will be using. And the reason why we're given our current is because if we look where we want to find our 5 ohm resistor, the current is in series for this entire circuit. If a current is in series, that means the current across all of these resistors is the same. However, the voltage is different. That's why we're using this instead of the voltage times current formula. We know our resistance to be 5. However, we don't know the current. The reason why we can't use the current that's provided, the 20 amps, is because when current flows through parallel circuits, it is divided. So when it flows in here, part of it is lost, and then when it flows in here, part of it is lost before even getting to this part. So how do we solve this? Well, what we can do is note that the voltage for this resistor, the voltage for this resistor, and the voltage for these combined resistors is the same, because voltage in parallel is the same throughout the system. And what we can do is find this voltage, and after we find the voltage here, we can find the actual current flowing through the right side of our problem and then use that in our power formula. We need to find the total voltage of our system, so we're going to set our Vs equal to our current S, which is our initial current, times our total resistance. If we plug in our values, we're going to get that V of S is equal to 20 amps times the 3 ohm resistor that we found. This will give us 60 volts. So the entire voltage is 60. Now we want to find the current flowing through all of these resistors, again because the current is going to be the same, and then we can use it in our power formula. We're going to say that our voltage source divided by our R total for this entire right part, which is in series, is equal to the current that we need to find. Our voltage we just found to be 60 volts. We are going to be dividing this by the total resistance of our right side, again because it's in series and a current going through a series circuit is the same throughout. So this is being divided by 15 ohms. If we do this, we are going to get that our current is equal to 4 amps. And now we know the current, 4 amps. We can plug this into our power formula. And after we do this, we are going to get 4 squared, which is 16 times 5. And this is equal to 80. So the power absorbed by our 5 ohm resistor is 80 watts. So this is how you do this type of problem. If you found this video useful, consider giving a like. If you have any questions about the material covered in this video, feel free to leave them in the comments down below. Lastly, if you want more problems like this, there is a playlist in the description with an entire overview of Introduction to Circuit Analysis.